Yes, what is the answer?
10.15 seconds.
10.15.
10.19 seconds.
Okay, okay. 10.18 second. Okay, that is the exact answer. Okay, so how to find out this? Let's understand first. First, you find out the lambda charging time constant R and C. So RC gives the 8. As you know the equation, V is equal to V into 1 minus e raised to minus t upon t. So sorry, this example, yes, RC is you get 100 into 10 raised to 3, that is your resistance, multiply with the capacitor which is 50 microfarad, so you get the 5. Clear? That is a constant. So V is equal to Vc is equal to V into 1 minus e raised to t upon lambda, that is the equation. So here you need to find out the time taken by this capacitor to charge up to the 200 watt. Means now assume that the capacitor voltage is 200 watt. So Vc is 200, your supply voltage V is 230. Charging time constant lambda is 5. So you find out this e raised to minus t about 5. So you get the 0.1305. So you get e raised to t by 5. Inverse of this 7.66. So if you take anti-log t by 5, so here log 7.6687. So that gives a value of time t 10.1857 seconds. Okay. So it means that this capacitor requires 10.1857 seconds to charge up to the 200 watt. Clear? So that is the answer of this example. Anyone doubt in this example? Any doubt, Shama? Yes or no? Anyone have a doubt?
No, sir.
Okay,
No, sir.
so move for the next topic. That is nothing but discharging of the capacitor. First, we see how the charging process happens in the capacitor, and we derive the equation of it. Same way, how the discharging of the capacitor is happen. Okay, so same circuit diagram here, same supply voltage is given here. So as we see in the previous theory, that suppose the switch at the position A. Yeah? So at this time you can see that capacitor and resistance that is connected in series with the source. So at this time your capacitor is charged. Okay, but after once it is fully charged and this switch is suppose move at the point B. So what happened? Your source is disconnected from this RNC. Now your switch is at the position B. Now there is no source, but at this time your capacitor is fully charged with the supply voltage. Okay, so at this time your capacitor is start discharging through this resistor. So here we assume that switch is now in position B, so the capacitor start discharging. So now what is the voltage across the capacitor during the discharging with respect to time? Okay, so let's derive this equation. So as I told you before, at position A, it is the charging time of the capacitor. So capacitor is fully charged. So now your supply voltage, capacitor voltage becomes same as the supply voltage. Suppose here V0, so capacitor voltage becomes V0. Now we move this switch to the position B. So now capacitor start decreasing and voltage across this start decreasing. So let's assume that at any time during the discharging, the voltage across the capacitor is Vc, or potential difference across the capacitor is Vc. I is the discharging current and Q is the charge on the capacitor. So as we know that charge is equal to what? C into voltage across the capacitor. That is nothing but Vc. So as we same way apply the KVL. Supply voltage, here there is no voltage, supply voltage, so it is 0, is equal to voltage across capacitor plus voltage drop across the resistance. So Vc plus IR. So as you know that current I is equal to what? Dq by dt. Q is C into Vc. C is constant. So here differentiation of Vc. So it is C dVc by dt. So here in this equation we replace this I by C into dVc by dt. So Rc into dVc by dt. So here if you make the equation of dV by Vc, if you take this Vc this side, so here this becomes Vc is equal to minus Rc dVc by dt. So dVc by Vc becomes minus dt upon Rc. Now take the integration both the sides. So after taking the integration, what we get? It is log V. Okay. So log V is equal to integration this side, it is dt upon Rc. So it is minus t upon Rc plus K1. K1 is the constant of integration, which can be determined from the initial condition. The same as the charging process, here we determine the constant from the initial condition. So now during the discharging process, what is the initial condition? So when we put this switch at the position B, at that time your voltage across the capacitor is how much? Same as the supply voltage, because it is fully charged. Because before we move switch B at the position B, initially at position A. So at position A, it is fully charged, this capacitor, by the supply voltage. So initially at T is equal to 0, during the discharging process, the capacitor VC is same as the supply voltage. So we assume that supply voltage is V. So you can see that VC is equal to V at T is equal to 0. Okay? Initial condition. So put this value here in this equation number 1. So VC is V, so it becomes log V. T is 0 because initial time, so it becomes 0 plus K1. So K1 is become what? Log V. So put this value of K1 log V in this equation number 1. So that becomes log VC is equal to minus T upon RC plus K1 is replaced by log V. Okay? So this log V come to this left hand side, so this becomes log VC divided by V. Minus is equal to minus T upon RC. Okay? So VC by V is equal to anti-log e raised to minus T upon RC. So VC is equal to what? This V is multiplied here, V into e raised to minus T upon RC. And RC is what? Discharging time constant. So it is replaced by lambda. So it becomes V into e raised to minus T upon lambda. So this is the equation of voltage across the capacitor during the discharge of the capacitor. Okay? Charging equation is what? VC is equal to, charging equation is VC is equal to 1 minus e raised to minus T upon RC. You can see this. Okay? Charging time equation of the capacitor. Yes, this one. VC is equal to V into 1 minus e raised to minus T upon RC. So you can see that here, as the time passes, the voltage across the capacitor is increasing. Here, but here in this equation, discharging process, you can see that if you follow this equation, as the time passes, what will happen? The voltage across the capacitor, that is gradually decreasing. Why voltage decreases? Because your capacitor is discharges, so charge on the capacitor, that is decreasing. So as the charge is decreases, the voltage is decreasing, because charge is directly proportional to the voltage, or voltage is directly proportional to the charge. Okay. So here in the discharging process, your voltage will decreases. This is the discharging process of the capacitor. I hope all of you understand this charging and discharging process. So in the next practical number 4, it is practical. So I think you can understand practically also how this charging and discharging process happen in the capacitor. So here I complete this chapter number 3. I think all of you clear this. Is there any doubt in this chapter number 3? Anyone? Yes? Anyone? Yes or no? Is there any doubt? So I can move for the next topic.
Yes, sir, you can move.
Okay, okay, thank you. So in your syllabus, first internal syllabus, this is your 3 chapter. So you prepare
So what
this.
is the paper pattern?
Yes, what is the
Paper pattern?
I will share you paper pattern, okay? And I will share you the question bank also. What type of question can be asked in the exam? Okay, so don't worry about it. So in the second chapter is missing. I think it is not missing, but first we decided that to remove this star data transformation from your syllabus. But after the discussion with the other faculty members, we decided that to add this topic in your syllabus. Okay, so second chapter 1 topic, star delta transformation, that I will cover in this lecture. That is the remaining topic in your second chapter, star delta transformation. Okay, this is the topic of second chapter. So let's start the star delta transformation. So first of all, give me the answer that what is the meaning of this star and delta, and where we use this star connection and delta connection in the electrical circuits. Can anyone give me the answer? Where we use the star connection in which type of system or delta system?
To reduce the circuit.
Yes, to reduce the circuit, obviously we use the star delta transformation. But my question is that when we require the star and delta type of connection, in which type of the circuits, which type of electrical circuits, or which type of the load we require this type of connections?
Non-planar.
No, no.
It is used in distribution of circuit. I mean distribution.
Have you learned the polyphase circuit in your physics subject in your 12th standard? Polyphase circuit or
No.
three-phase circuit?
No, sir.
No, sir.
Okay, okay. So
No, sir.
as you know that at your home there is a single phase supply, 230 watt single phase supply. Okay, but for the three-phase supply, three-phase power, which is a 415 volt power. Okay, so for the three-phase supply, where we require, where you have three-phase load. Okay, three-phase load that may be connected in star fashion or it may be connected in delta fashion. Okay, so this type of configuration you can see in the polyphase circuits. So this is a three-phase load. At your home, there is only one resistance or only one conductors. One is a return conductor. Okay, but in the three-phase system, there are three phases. So suppose assume that this is the phase number A, B, and C. Okay, so phase A connected with the phase A resistance, this RA. Phase B that is connected with the phase B resistance, RB, and phase C that is connected with the phase C resistance, RC. So in the three-phase type of the load, you can get this type of configuration, star as well as this delta type. Suppose it is delta connection, then your A phase is connected with this terminal, B phase connected with this terminal, and C phase with this terminal. Okay. So star delta configuration of the load you can see in the three-phase or polyphase circuits. Okay, that we will discuss in the next chapter, polyphase circuit. That is another chapter in your syllabus. So here, basically the meaning of this star delta transformation is, as I told you by one student, that is used to reduce the circuit. Okay, so when you find out the equivalent resistance of any complex circuit, in that you can see the sum of the circuit, there is a star fashion of the load and some of the resistance are connected in delta fashion. Okay, so during the reduction of this circuit, to calculate the current from the source, you need to reduce this circuit and find out the equivalent resistance. So at that time, you require the transformation from star to delta or delta to star to reduce the circuit. Okay, so that's why we use this star delta transformation. So first we see the star to delta transformation, means how to convert your star connected circuit into delta connected circuit. Okay, and then after we see the delta to star transformation, means how to convert the delta connected circuit into star connected circuits. Why we use the reduce the circuit. Clear? We use this type of transformation to reduce the circuit to get the answer more quickly with less complex calculation. Okay, so let's see this, how to convert this star connected circuit into delta connected circuit. So you can see here there is a star connected point. This is A point which has a resistance RA, B point which has a resistance RB, and this is a C point which has a resistance RC. Now I want to connect this star into this delta fashion. Okay, so what is the equation and how to remember this equation when you convert this star into delta fashion? So here in the star connection, we call the resistance of terminal A RA, B terminal RB, C terminal RC. Here in the delta connection, we call the resistance between A and B called RAB, small subscript RAB. B between B and C, we call R subscript BC, and between C and A, we call R subscript CA, because it is between C and A. Same way it is between A and B, so we call RAB. It is between B and C, we call RBC. So how to find out RAB, RBC, and RCA from this star connection? So to find out RAB first, what you have to do? You have to first make the addition of the resistance which is connected at point A and B in your star connection. So here we find out RAB in your star delta connection. So take the addition of RA point resistance plus RB point resistance. It means RA plus RB, plus multiply both the resistance RA and RB and divide with the opposite resistance or remaining resistance. So here we take RA RB, so remaining resistance is only RC. So RA RB addition plus multiplication of RA RB and divide with the remaining resistance, which is RC. So by this way, you can find out the value of resistance between terminal A and B in your delta connection. Okay. Take the value from the star connection. Okay, remember here. See, here we take the RAB. So take the value of A terminal resistance, B terminal resistance addition plus multiplication divided by the remaining resistance. Same way RBC. So here we find out the resistance in the delta connection between B and C. So in the star connection, take the addition of B terminal resistance and C terminals, which is RB and RC. Plus multiply both these things, RB and RC, and divide with the remaining resistance, which is RA. Clear? Same way, find out the resistance between C and A point in your delta connection, RCA. So RCA means addition of C and A terminal resistance in your star connection, RC plus RA, plus multiplication of both and divide with the remaining resistance, which is RB. So by this way, you can remember these equations doing the transformation from star to delta conversion. Clear all of you? This one? How to remember this equation? So during the example, when you require to connect transformation from star to delta, first draw this circuit, this type of the circuits. Make the same point. Suppose here it is A, B, and C. You take same here. You take first A, B, and C in this fashion. Okay. And calculate one by one all the branch resistance between AB, between BC, and between C. Equation. All of it clear? Star delta transformation is equation. Any doubt?
Yes, sir.
Okay. So let's understand how to convert delta to star. Suppose in the delta connected circuit in your figure, we require star type of connection to reduce the circuit. So same value RAB between AB, BC, RBC, and between CA, RCA. Now convert this into star. So in the star, as you know, at point A, resistance we name RA, at B, RB, and at C, RC. So we first find out this RA. Okay. So RA, for RA, find out this from this delta connected point. So here we find out the resistance of A point here, RA branch resistance. Okay. So in your delta connected, the whatever resistance which is connected at point A, that multiply first. It means RAB and RCA both are connected with the point A. Yeah, because here we find out the RA of your star connector. So whatever the resistance connected with the terminal A in your delta connected, first you multiply RAB and RCA and divide with the sum of all the resistance of your delta connected. It means RAB plus RBC plus RCA. I again repeat this. Suppose you find out the A point resistance in your star connected, then find out its delta equivalent. Find out from its delta equivalent. So at point A in your delta connected, whatever resistance is connected, multiply first. It means here is RAB and RCA. So you can see RAB and RCA, and divide with the sum of all the resistance of this delta connected, RAB, RBC, and RCA. Now same way, find out B point resistance, RB. So whatever resistance is connected at B point in your delta connected, first multiply RAB and another is RBC. So here you can see that multiply RAB and RBC and divide with the sum of all the resistance, RAB plus RBC and RC. Same way you find out the C point resistance, RC. So whatever resistance is connected with the C point in your delta connected, first multiply, which is RCA, and another is RBC, and divide with the sum of all the resistance of the delta connected. So there is a simple equation to remember this during the delta to star conversions. All of you clear this one?
Yes, sir.
Okay, so let's calculate the example so you can understand that how to reduce the star to delta or delta to star during the reduction of the circuits. So let's start the first example. Draw this figure using star delta transformation. Determine the resistance between terminal A and B in your given circuit. So here A per point is here at this point, B point is here. Yeah. So here first identify which resistance are connected in series, which resistance are connected in star or which connected in delta. So by the conversion into delta or star, how can you get reduce this circuit? Okay. So first you find out the delta or star configuration in your circuit. Then after you start the reduction of the circuit. Okay. So let's first understand. Okay, first draw this figure. Then after we understand how to reduce the circuit. So have you any seen any delta connection or star connection in this?
Sir, between the 10 ohm, 5 ohm, and 20 ohm resistor, is it a star connection, sir?
No, 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 no. 10, 5, and which resistance you say there?
Sir,
The
5
10,
ohm,
5,
15 ohm, and 2 ohm.
and
No. You can see this
Sir,
box.
2, 5, 10.
So you can see this box. This is a delta connected. Okay. See, C point is common. So this 5 resistance is connected with the C point. This 15 ohm resistance is also connected to C point. And this 20 connected between A and B point. So this is a delta connected. Yes or no? A, C, B. This one box.
yes, sir.
Okay. So
Sir,
first reduce
2,
this
5,
circuit.
and 30.
Yes, 2, 5.
30 in star.
Yes, it is in star. Yes, this one is in star. But if you before reduce this delta connection into star, then your circuit becomes very simple. Clear? You can see number of star and delta connection in this circuit. But first thing that by reducing which delta to star or star to delta, you can reduce the circuit very easily. Clear? With less calculation. So here we can see the number of star or delta circuit fashion. Here this 2, 5 and 30, that is also star. Here 10, 25, that is also look like in star. Same way 25 and 50 also in star. But you identify the point where you can reduce the circuit very easily. So if you reduce this delta connection first, then you can reduce this circuit very easily. If you see this. If you convert this 2, 5, 30 into this star into delta, then again this circuit becomes complex. Okay, here we not want to make this circuit complex. Here we want to reduce this circuit. Okay, so first think about that. By reducing which part you can simplify this circuit, or you can reduce this circuit in minimum steps. Okay, so here I identified that this 5, 20 and 15 ohm delta connected point, if you reduce this star or convert this this delta into star fashion, then you can easily convert this circuit into very reduced form in a simplified manner. Okay, so let's convert this delta into star. This is a invert delta. Okay, because A, B point here 20, A and C between that 5 ohm, B and C that is a 15 ohm. So this delta that is invertly connected. That is a reverse of delta. Okay. So convert this delta into star. So for the
Sir,
star
can
and
you
delta,
show the sir, can
yes,
you show the formula once again so
yes, yes,
we try it
yes. All
ourselves?
of you, please write down this formula first. Yes, yes. First, write down the formula for star to delta conversion. This one, and then after delta to star. First of all, write down this.
Sir, you are not audible.
Yes, I have not speak anything. You just write this equation.
Okay.
Then after I move for the example. Okay. All of you written this equation? RB, RBC and RC.
No, sir.
Yes, sir.
Okay. Then write down this equation of delta to star transformation. All of you must draw this figure and then after write down this equation. Okay. So you can understand that this is a delta to star conversion. RA, RB, RC, that is the resistance of the star connection. RAB, RCA, that is all the resistance of this delta connection. Okay. So first draw this figure and then after write down this equation. So this arrow shows that this is a conversion of delta to star.
Done, sir.
Okay, okay. So let's move for this example. Using star delta transformation, determine the resistance between terminal A and B. All of you have drew this figure. I draw this figure.
Yes, sir.
Okay, so let's understand this first step. So as I told you that you can find number of delta and star circuit in this figure. Okay, but first identify that which delta or which star you first convert so that your circuit becomes very simple. Okay, so here I find that this delta 5, 20 and 15 ohm, which is a delta circuit. First I convert this delta into star, then my circuit becomes very simple. Okay, so let's first convert this delta fashion into the star connection. So here you can see that this is delta AB, that is a 20, AC this is 5, B and C this 15. Okay, this one, this highlighted portion. Okay, so first convert this delta into star. So if convert this delta into star, so it is look like this way. Yes or no? So here between at point A, that is the resistance RA, at point B, that is the resistance RB, and at point C, that is the resistance RC. So if you convert this delta into star, so it is look like this way. All of you clear this one? Yes or no?
Yes, sir.
Okay. So now we want to find out what first? A point resistance, which is RA. So what is the equation for RA? Delta to star conversion?
RAB into RCA by RAB plus RBC plus RCA.
Yes. So in short, you remember that whatever the resistance connected point A in your delta, first you multiply. Yes, which is 20 and 5. And then divide with the sum of all this delta connected resistance, which is 5 plus 15 plus 20. So you can see that RA is equal to multiplication of 20 into 5 and divide with the addition of all the resistance of the delta connect, which is 40. So you get the answer of RA, that is 2.5 ohm. So in your star connection with point A, the resistance RA is equal to 2.5. Clear? Same way, find out the B point resistance RB. So again, at point B in your delta connected, two resistance 20 and 50. So multiply this 20 and 50 and then divide with the addition, which is 40. Clear? So RB is equal to 20 multiply 50.
7.5.
Yes, you get the 7.5. Yes. Same way, find out RC. Give me the answer.
1.8.
1.875.
Yes, yes. Yes, 1.870. Clear? So write down this value. RA is equal to 2.5 RB is equal to 7.5 and RC is equal to 1.87. And put this figure or replace this delta in your main circuit with this type of circuits. Clear? So you can see that this RA, which is connected in series with this 10 ohm, yes or no? Yes or no? With point A
Yes,
here,
sir.
Yes,
with
sir.
point A, this RA, that is 2.5 ohm, that is connected in series with this 10 ohm. Same way, the B point resistance, which is what, 7.5, that is connected in series with this 5 ohm. Clear? And same way, the C point resistance in your delta connection, which is what, 1.87, this one, that is connected in series with this 2 ohm resistance. Clear? Now it is look like this way. You can see this here. A point in series with here is the 10 ohm resistance in series with this is a 2.5 ohm. Clear? B point here 7.5 in series with this 5 ohm resistance. Clear? This is RB, which is connected in series with 5 ohm. Same way, this RC 1.87 that is connected in series with this 2 ohm. Clear? So both are in series here. 10 plus 2.5, so that becomes 12.5. 7.5 that is in series with 5, so it is again 12.5. And here this 1.87 that is in series with 2, so it is 3.87. So if you reduce this circuit, so it is look like this way. You can see here. It is 10 plus 2.5, it is 12.5. Here it is 7.5 plus 5. Plus here 25, that is also connected in series. Okay, you can see in the main circuit diagram. 5 and 25, that is connected in series. And that in series, this B point resistance, which is 7.5 and again connected in series. So that gives a 37.5. 7.5 plus 5 plus 25. All are in series. So get 37.5. So you can see that here 37.5. And that is connected with point B. So you can see that that is connected point B here. And this middle line, which is 1.87 and 2. So that is 3.87. Clear? This reduction up to this point?
Yes, sir.
Clear? Now,
Yes, sir.
now how to reduce the circuit between A and B? Your A point is here, B point is here. Now here we give the name of node. This is node number 1, 2, and 3. So you can see two delta type connection. Clear? One is 1, 2, and 3 here. This is the delta fashion. And another is 1, 2, and B. That is also delta fashion. So convert any one delta into star connection again. Clear? So here first I convert this delta, which is between 1, 2, and 3 point. It means 12.5, 3.87, and 15 ohm. First I convert this delta into star fashion. Okay. So you can see this. I get the equivalent resistance like this way. If you find out this star to delta, first of all, convert this delta into star, this point between 1, 2, and 3, and give the answer of RA, RB, and RC, or whatever you want to give the name, R1, R2, or R3. J per name aapko chance. First, convert this delta into star. Or if you understand this?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So this 12.5, 3.87, and 15, this delta convert into star and give the answer of same like this way, RA, RB, and RC. Use the same equation, this one. What is the value of RA or R1?
19.59.
1.54.
1.54. R2 or RB?
1.85.
R3 or RC?
5.97.
Okay, so you can see that your circuit is look like this way. 1.54 that come into series with 37.5. Yes or no? Your this R1 or RA in star connection that come into series with this 37.5. Yes or no?
Yes, sir.
And R2 or RB, whatever you say, that come into series with this 30 ohm. Yes. And your 5 point RC, which is 5.9C 97, that is connected with the terminal A. So you can see that this star connection 5.97, 1.54 and 1.85. Clear? You can draw this circuit like this way. 1, 2, 3 delta into star, this one. Yes or no? Think about it. It is, you can draw like this way. Yes or no? 1.54 in series with 37.5 and 1.85 that is in series with 30.
So 1.54 is RA.
Yes, it is R1, RA or R1, whatever you say. Yes.
Yes.
So you can see in this figure here, this is this point. It is connected with point 1. So it come into series with this 37.5. Yes or no? It is same like here. You can see the previous point. Here you find RB, that is what 7.5. That come into series with what? 5 ohm and 25 ohm. Yes or no? Yes or no?
Yes, sir.
Same way here, that this 10 ohm that is connected with point A. So what is RA you get here? This is 2.5. So this 2.5 that is come into series with this 10 ohm. You can see here in this circuit. Here. So same way here, the point A in star connection you get the resistance what? This 1.54. So in series you can connect this 37.5. Now understand or not?
No,
Now
sir.
say,
Sir, how I had a question, doubt, sir.
okay. So okay, let's understand again. So here suppose this is a delta 1, 2 and 3. Okay. So how to draw the star within this delta? So here at point A you get one resistance here. Yes or no?
Yes,
And
sir.
one resistance is connected here like this way. See
Yes.
this my cursor, so you can understand this. One resistance here connected with this 2 point here like this way, and one resistance is connected with this A point like this way. Clear?
Yes.
And this
Clear.
delta is removed now. This delta is removed because we convert this delta into star. So only resistance is what? This A point is resistance RA, and this automatically this 37.5 become in series with this RA or R1. Same way this R2, this resistance automatically come into series with this 30 ohm because this 3.87 is automatically removed because convert this delta into star. Clear? Delta fashion તમે remove કરીને star માં convert કરો છો. Okay. So now only star fashion resistance is present. Clear? So one point or RA point, that resistance now becomes what? 1.54. You can see here this 1.54. Clear? This one. This is a conversion of your delta to star. This point and this point is connected with 2 and this point is connected with the A point. I'm talking about this circuit, only this portion. Clear? This portion is as it is. This automatically come into series with 1.54 and 1.85. And here point B is connected. You can see in the original figure here. 37.5 and 30 ohm. Both are connected with the point B. Clear? That part is as it is. But to convert this 1, 2, 3 delta into star, a point which has a resistance 5.97, 1 point which has a resistance 1.54, and 2 point which has a resistance 1.85. So this both the resistance 1.54 and 37.5 come into series, and 1.85 that come into series with 30. Now understand or not?
Yes, sir, it is clear.
Yes, sir.
Clear all of you? Any doubt still? So again repeat this thing. If you not understand this, just draw the star equivalent within this delta connection. Draw the star connection within this delta so you can understand this. And then after remove this delta. Once you convert this delta into star, remove this delta and make your star as it is. I again tell you that once you convert this delta into star, first draw the star connection within this delta. So 1 point, draw the line here. Then second point, in the star fashion, connect with the line B, and third line which is connect with the line with the point C. Clear? Then after remove this delta and see the circuit. So it is look like this way. This way. Try it. Understand now? All of you?
Yes, sir.
Okay. So this 1.54 and 37.5 in series. So its equivalent is 39.040. 1.85 and 30 that is in series. So its equivalent is what? 31.85. Clear? So it is look like this way. You can see this. Yes or no? Both are in parallel between A and B. So
Sir?
yes.
Sir, I got I equivalent.
Yes, what is the I equivalent?
23.51 ohm.
Yes. So first of all of you understand this thing up to this point? Yes or no? બધાને ખબર પડી ગઈ છે?
Yes,
Okay. So first convert this parallel 31.85 and 39.05 equivalent. So you get 17.54. In series, you get 5.97. So your answer is 23.51. All of you get this answer?
Yes, sir.
Is there any doubt now? So I can move for the next example very quickly. Yes or no, all of you?
Yes, sir.
Okay. So write down the
Yes,
second example. Calculate the current supply by the battery in your network of figure. The network of figure, this figure. Find out this supply current, I. Supply voltage is given 49 volt from this circuit. So how you get the supply current? So first you need to reduce this circuit into equivalent resistance. So here you can see there are number of delta fashions. So which delta you first convert into star so that you get the answer very quickly. So if you see that, you can find the three delta. One is ACB, another is CDE, and third one is BCE. This one. Yeah. So convert any one delta here into star and see that how you can reduce this. So here first I convert these two delta. One is ACB, that is the one delta, into star, and then after convert this CDE, this delta into star. Clear? So try it. Again repeat. If you not understand how to draw from delta to star, first draw the star connection within this delta. So here in the middle of this delta fashion, draw one point. From that, draw the three line. One is connect with point A, one is connect with B, and another is connect with the C point, like this. And then after, remove this delta. Then after you can see that the equivalent circuit. Same way in the lower delta also. Give me the answer quickly. Value of this first delta, RA, RB and RC.
0.66, 1 and 2.
RA is 2.3, it means 0.6, RB is 1 and RC is 2. All of you get this answer? This first delta
Yes.
into star.
Yes.
Okay.
Yes, sir.
And how to draw this? You can understand this. First draw the star within this delta and then remove this delta. Okay. Then second delta 2, 5 and 3 that convert into star. So that resistance RC is 1, RD you get 3 by 5 and RE is 1.5. All of you get this answer? 1, 3 by 5 and 1.5.
Yes, sir.
Okay. So now your circuit is look like this way. You can see this. You can draw the circuit is look like this.
Yes, sir.
First your delta, that is you converted into star. So your RA and RB at the horizontal plane and RC that is at the lower line. So it is look like this way. You can see that. RA that is 2.2 by 3, RB that is 1 and RC is 2 here. So you can see here star. Same way this another delta which you converted into star, RC you get 1 ohm. So this RC come into series with this RC of first delta. Clear? Then this RD 3 by 5 and RE 1.5 that is look like this way here. Clear? And this 3.5 that is as it is. You can see that 3.5 here as it is in your main figure. Clear? So your equivalent circuit now it is look like this way. So here 1, 3.5 and 1.5 all three are connected in series. So give the 6 ohm, 2 and 1 ohm both are in series. That gives a 3 ohm resistance. So again you get the delta connection of these three. Once you get any box of resistance or any three branches in closed pattern, it means this is a delta connection. Clear? So this is the first branch. This whole is a one branch parallel. So it is 3 parallel 6. Yes or no? All of you? 3 parallel 6?
Yes, sir.
So it is equivalent to. So now these 2 ohm equivalent of 3 and 6 that come into series with this 2 by 3 and 3 by 5. Okay. So finally you get this equivalent circuit. Yes or no? 2 by 3 in series with 2 in series with 3 by 5. So now all are in series. So there is an addition. So that gives the equivalent resistance. You have supply voltage. So voltage divided by equivalent resistance, you get the supply current. That is your answer. All of you understand this? Or I can repeat again? Repeat करवानी जरूर है?
Sir, can you show the question? What is it saying? Or we have to find the supply current at the end?
Yes. Only find the supply current. Calculate the current supply by the battery in your network. Just find out the supply current I.
Okay, sir.
15.03 ampere.
Yes. What is the answer? 1 point.
15, sir. 15.03.
Yes. It is almost. Yes, it is 15 ampere. Almost 15 ampere. Your R equivalent is 49 divided by 15. So current is voltage divided by equivalent resistance. So you get the 15 ampere. So I think all of you now understand that how to convert this star into delta or delta to star. Okay. So I give the one example for your homework. Write down this example. Determine the current in 17 ohm resistance in your network. 17 ohm resistance is here between C and D point. Your supply voltage is 115 volt. So convert this, find out this current from this 17 ohm resistance. This example I give for the homework. Quickly draw this figure. So here I stop this lecture because time is over.
Sir, can you tell us the syllabus for the first test, sir?
Yes, there is a first, second, and third chapter. All topic of first, second, and third chapter, and also this star delta transformation also. Okay, that is in your second chapter.
So will it be MCQ type or objective?
Yet we not decided here the pattern, but I will give the pattern in 1 or 2 days. What type of question can be asked? But
Okay.
generally we ask some MCQ, short question, as well as descriptive question. So all type of questions can become in your exam, as well as example also. Okay.
Sir, theory or only numerical?
All the things. As I say that I can ask all the things: MCQ, short question, descriptive type, as well as example. So all these 4 type of question will become in your exam.
So are derivatives included?
Yes, yes. Derivative included in your descriptive type question. Like derive the equation of equivalent resistance calculation during the series connection, parallel connection, and same like derivation of relationship between electric potential and flux density, as we derive the equation D is equal to epsilon 0 into E. Clear? So this type of derivation come into the descriptive type questions. I will share the question bank so you can understand that what type of questions can be asked in the exam. Okay. So don't worry about the exam. I will share the question banks so you can understand that what type of questions will be coming. Okay.
On Microsoft Stream, you have uploaded till lecture 7. Can you please upload the remaining videos?
Okay, okay. I will upload it. Okay. Okay.
Thank you, sir.
Is there any doubt? Anyone? બીજા કોઈને કઈ ડાઉટ છે? પૂછવું છે કઈ? Yes, anyone?
No, sir.
Okay. So let's take your attendance first. So now you can leave this meeting.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.